back to the shop. My name is Brad. Today's project is going to be a lathe project, and it's going to be for the What's in Your Box Toolmakers collaboration. The project that we're doing today is a lathe ball turner. It's a tool holder that mounts on your lathe that allows you to turn knobs and round work. So I'm running this particular build, and we got a couple of guys making different parts. The part I'm making today is going to be the main body part. Now that mates with the mounting bracket, and it's going to hold the tool holder. So it's we're going to start off with some 3-inch radius. some 3-inch diameter stock, and it's pretty simple. We're going to cut a slot in it. We're going to turn a couple of shoulders that will, let it fit into the base. Drill a couple of holes, and that really should be it. It's pretty easy project to make. So let's get started. So we have a piece here made from Jaster, the guy from Journey to Journeyman channel. He made this base. He has a video for it. We have the link in the video, in our video now, so you can watch that being made. We have some metal that was donated from Mike over. His channel is Blue Hands Video. So thanks, Mike, for the piece of metal. He selflessly donated this, so I really appreciate that. So he's part of the build as well, coming up with material. So what we need to do is I'm going to make this part right here. This is going to rotate on here. It's going to hold the tool, be able to adjust it. So it's a pretty simple piece. We'll turn it down to diameter. We got 2 steps that we have to turn. We're going to drill and tap for 1/4 so it can bolt through here and and be held in place. We have a hole that's coming in off on this side here, which is going to accept a handle, and then we have these 3 little set screw holes to bind the tool holder in place. So let's get set up in the lathe and get started. All right, just double check. We got a 3-inch piece. All right. Four-jaw work. I'm having some flashbacks to the 4-jaw competition. I can feel Adam's presence standing over me. So I'm using this guy here, this permanent magnet Noga. This is my dedicated 4-jaw chucker. Alright, that's good for now. It's good to take a facing cut. So I just took a skim cut across here. What I need to do is I need to turn this down to 2 inches, 2.5 inches, right? So 2 inches, 500 thousandths. Took a measurement, and we have 968. So we're going to just start taking some diameter down until we get to the 250. Alright, we have 120 thousandths left to go. I'm going to swap out this carbide insert tool, and I'm going to put some high-speed steel in here because I want to get a nice finish. And you know, this machine is not powered yet enough to really get good finishes with the carbide because of the RPM and the the motor. You know, it bogs down quite a bit. It's supposed to have a 2 horsepower motor. It's supposed to come stock with a 2 horsepower motor. I'd like to have a 3 horsepower, but the previous owner of this machine swapped it out for a 1 horsepower motor, so it's underpowered by 50%. So what we're using here is a AR Warner insert. This is high-speed steel. It's been freshly honed. You know, the top just took any kind of buildup off of it, and we should be ready to go. These are pretty good tools. I can also bring the RPMs down on this machine so I don't have all that nasty vibration. Now, I started this at 120,000, so I have plenty of time and material to dial in a good cut. I'll tell you right now, that finish is silky smooth. I don't care for the chip though, it's a little stringy. I probably could bump up the feed rate a little bit. Well, now it's throwing a nice chip. You know, these inserts don't have any chip breakers, so you kind of get a continuous, you know, curly chip. Yeah, just as I suspected. It's like glass. Let's just get a quick measurement on this. 572. So let's reset our axis here. Big, long, curly, but what a finish. Gorgeous finish. Alright, I'm taking 20 and leaving 20 for a finish cut. Take a spring pass. Yep. All right, we got 20 thousandths to go. So what we're going to do is slow the feed down. Come on, gearbox. We're going to use our little easy lap here. We're going to take off any build up on the top. Make sure we have a nice clean surface. Beautiful. And what I'm going to do is I'm going to take 519 off, and I'm going to polish out. I'm sorry, I'm going to not 519. I'm going to take 19 thousandths off, and I'm going to polish out the rest. That is some smooth finish. Doesn't look like it, but wow, it's real nice. Looks like we got about 1,500, which isn't all critical, but what I'm going to do is get some emery and polish it. So what I want to do first is get all these big chips out of here. Then I'll cover my ways. A little drop rag right there. That's nice. Now we're not looking for, super high polish here. We're just trying to get the machining marks out, make it look nice, presentable. We're right at 2.5 inches, dead smack on the money. So what I did was I kind of just snuck up on it with the emery cloth. Now I'm going to just use a little Scotch Brite just to even out the finish. Try to give it a little bit of a brushed look if I can. The one thing I do want to do now is put a little chamfer on it. So basically the side that I'm going to chamfer is going to be the top portion. So I just want to break the edge. And that's it. I think before I'm done I'm going to just take another facing cut. Just to clean this up a little bit and make it, take a nice finish cut, because then we're going to lop this off in the bandsaw. So let me set up, let me just take a quick finishing cut off the face, and that'll be that. Beautiful. That is nice. I'm liking it. Alright, let's go cut it down now. Alright, we got our soft jaws mounted. We got the piece chucked up the 4-jaw chuck. We got it indicated in. I'm going to remove the saw marks. And we're going to take a measurement then. I first got to just get this straight. Alright, looks like all the saw marks are out. Now what we're going to do is we're going to use a depth mic, and I'm going to measure to the bottom of this chuck, and we'll see how much we got to go. We're looking for a total depth of 1 inch 420. Alright, we're at 1 inch 496, so we got plenty of meat. I do got to take some steps, but I do want to get an accurate measurement on here. What I need to do is I need to switch out the anvil on here, get a bit of a longer one. Be right back. Okay, we got 1 inch 493. Yeah, 493. 493 minus 0.420. We got to go 73 thousandths. I zeroed out my z-axis. Zeroed out the z-axis on the DRO, and we need to go 73 thousandths. let's take a measurement. 1/2 thousandth away. We'll just run a little bit of polish on that and we'll call that perfect. Because again, this is going to be, this is the underside. Alright, now what we're going to do is just take a tiny little breaking of the edge. That's it. Now the next operation is I have to cut a step in here, and what it's going to do is it's going to leave a 1 inch and 5/8 little boss here, and then that's going to get drilled and tapped. So let's see here. Yeah, we have to go into a depth of 233 thousandths, and it's going to be 1 inch and 5/8 in diameter. One thing I want to make sure is that I have enough room to do the 233. Doesn't look like it. Man. Yeah, we're going to have all kinds of soft jaw interference here. Alright, I just did a test pass, and I'm hitting the soft jaws, but it's kind of not an issue. It's just going to make a little bit of noise. It's just little flaps hitting the tool, so we're going to try not to worry about it. And we're going to start our cut. We'll start off with 50,000. Let's get us a measurement now. Can we sneak the mic in there? No, we cannot. We're going to have to do this all by caliper. If our calipers will get in there now. Like 182. I don't want to hit the camera. This is difficult to do. One inch 821. That should be it. I'm going to take a measurement now. One inch 649.5, which is good because that will give us a little tiny bit smaller to fit right into our piece. Which it does. Beautiful. Now what I'm going to do is I'm going to turn, there's another little nub right here. It's a I think it's 430 thousandths. Now that's going to be the little, it's like a little boss that goes into that hole, and then we're going to bolt it in. So we have to go in, we have to cut another shoulder, 115 thousandths. And then when I have the two shoulders, I'm going to use this tool that I ground right here and has a point on it, and I'm going to just get some relief in there. So let's start with that next one. So we're going to bring our x-axis all the way in, and we're going to zero that because it is zeroed. Okay. Let's touch off here. There, that's touch off for the z-axis. 115 thousandths in. So we'll move our z-axis 115 thousandths, and we're going to zero that. Alright, we got our facing tool mounted in, high-speed steel facing tool. I've touched off, I've set my DRO scales correctly, and what we're just doing is we're just coming in and we're just relieving that corner. Just like that. Same thing. This is a lot just by eye and just by using so that tool kind of puts like a fillet in. All we're doing is we're just gently relieving, and that's it. Now I got this video camera, it's actually clamped to the chuck, so I have to do this quick, but I'm trying to show you that you could see possibly the relief. That's it. Alright, the last operation that we're going to do now is we're going to drill and tap a 1/4-20 hole so we could bolt it to the main base. So we want to drill 3/4. Alright, time to tap. I switched out the tap handle here. This is a little bit more sturdier. I get a better feel. I'm going to clear them out now. Use a little hand deburr, Noga hand deburr. This is a way bigger screw than we need, but okay. The lathe work is done. Alright, we got Jay's piece here, Journey to Journeyman. We've got the lathe work done on my piece. Let's show you how she fits. Listen to that. Beautiful. Alright, next phase is to mill the slot and drill the 3 set screw holes and then the handle hole. So let's get started on that now.